Hello everyone. Today I'll be talking about a very important concept in machine learning, dimensionality reduction, and the difference between feature selection and feature extraction. The topic is especially important when we deal with datasets that have too many features. So let's start. Now, in the real world, many datasets have a huge number of features that is what we call high dimensional data. The problem with high dimensions is model become more complex, there's a lot of noise, training takes much more time, and overall performance can drop. So reducing dimensions helps keep our models simple, faster, and more accurate. Let's understand dimensionality reduction. Dimensionality reduction simply means reducing the number of features while still keeping the important information. When we do this, training becomes faster, overfitting reduces, data becomes easier to visualize, and the model focuses only on what truly matters. So overall, it cleans data and improves performance. Now, why dimensionality reduction matters? This process is crucial because it fights the curse of dimensionality. As the number of features increases, data becomes sparse, computation becomes expensive, and models struggle to learn properly. Reducing dimensions help the model generalize better, perform faster, and recognize patterns more clearly. Now, applications across domains. Dimensionality reduction is used everywhere. Image processing to reduce pixel complexity, text processing to simplify large vocabularies, genomics, where data sets have thousands of genetic attributes. Any high dimensional data set for easier analysis and faster results. It's a universal tool for ML practitioners. Now, two main approaches. There are two main ways to reduce dimensions. Feature selection, choose the best features. Feature extraction, create a new features from old ones. Both reduce complexity, but they work very differently. Let's look at both. Feature selection. Choosing the best. In feature selection, we pick a subset of the original features. The meaning of each feature stays the same. Nothing is changed or transformed. It helps remove noise, improve interpretability, and speed up training. Some methods include filter methods like correlation, chi-square, wrapper methods like forward selection, backward elimination, embedded methods like lasso and decision trees. Example, from 100 features, selecting the 10 most relevant ones. Now, feature extraction, creating new features. Feature extraction works differently. Instead of selecting existing features, it creates new features by transforming the original data. These new features capture the most important information but may not have a direct human understandable meaning. Popular techniques include PCA, LDA, autoencoders, TSNE for visualization, PCA turning 100 customers' preference features into just 5 principal components. Now, selection and versus extraction. Here's the key difference: feature selection, extraction. Feature selection keeps original meaning, it's simple, interpretable, removes irrelevant features, great for simpler models. So, the choice depends on whether you want clarity or compression. Whereas feature extraction has it creates transform features, complex and less interpretable it is, compresses data structure, and great for high dimensional models. Talking about the key takeaways now. To summarize, dimensionality reduction improves speed, accuracy, and generalization. Feature selection keeps original features, removes irrelevant ones, stays interpretable. Feature extraction transforms data into new features, very useful for high dimensional settings. Techniques like PCA, lasso, and autoencoders are widely used. Understanding both methods helps us build better, cleaner, and more efficient machine learning models. Uh, I hope this gave you a clear and simpler understanding of dimensionality reduction and the difference between feature selection and feature extraction. These concepts are essential for handling modern datasets effectively. Thanks for watching. I hope you like my video. Thanks for listening.